Morning guys, today we're looking at trigonometric identities. Okay, so we've looked at a lot of different parts, particularly unit circle. We've looked at, things like sine theta is the same as having, the inverse of sine theta is cosec theta and all these different types of stuff. So we're going to put it all together today and look at all the different trigonometric identities. So let's look at trig ratios and normal trig ratios. So we know sine theta equals our opposite over hypotenuse. Now these are simply ratios, they're not identities so much. Cos theta equals adjacent over hypotenuse, and tan theta equals our opposite over adjacent. So they're referring back to your sides of a right angled triangle. Now you also learned that three different ratios, which one was the cosec theta, which was the inverse of sine theta. Now you could write it as, I guess, O over h, but we want to write it as an identity, which means it's giving two different ratios and showing how they relate together. Okay, cos theta, sec theta is equal to the inverse of cos theta, again, so we're writing it as an identity, showing how they relate to each other. And cot theta we learned was 1 over tan theta. So if I wanted to find any of those three things, we need to find the sine, cos, or tan, or the respective ratio, and find the inverse of. We also learned when we looked at the unit circle that tan theta could also be written as sine theta over cos theta. Okay, that was referring back to our first quadrant triangle because sine was x, cos was x and sine was y, so y over x, opposite over adjacent. And also, if we look at cot theta, we know that cot theta is the inverse of tan theta, so that means we're going to put these upside down. We're going to find the reciprocal of those. So cos theta over sine theta. And again, that's an identity because they're relating to two different ratios. Okay, so they're our main ones that we've looked at mostly so far. Okay. Now, there are three other very important identities that we want to look at. If we look at the equation of a circle, hopefully remember the equation of a circle is given by x squared plus y squared equals 1 squared, so equals r squared, where x and y are a point on our circle, and r is the radius. So if we look at that, we remember looking at a unit circle, it's the same saying that's x and that's y, x across y up. So actually my formula, we know that x was same as saying our cos theta and y was our sine theta. So if we look for our theta and do opposite over adjacent, we can work out that our formula is actually cos squared theta, which is cos squared, plus y squared would be sine squared theta, equals r squared. Well, we know the radius is 1, so 1 squared is 1. So we've actually come up with a new trig identity relating cos and sine, I guess, that we haven't looked at before. Okay, and that comes, again, as you can see, derives from the equation of a circle and of our unit circle. Now, from that trig identity, we can then form two other identities by dividing. Okay, now I'm just going to rewrite that identity there, so we've got that nicely put. Cos squared plus sine squared, or sine squared plus cos squared, doesn't matter which way you have them around. Okay, now if I say I'm going to divide it all by, let's say, cos squared theta. See what happens. Something a little bit interesting. Well, cos squared theta over cos squared theta equals 1. Sine squared over cos squared is tan squared. Looking at the above one there, tan is sine over cos. And then 1 over cos, well, that's sec squared theta. So you can see how they all relate using these identities up top. Likewise, if I decide not to divide by cos theta, let me just rub that out, and let's say we divide by sine squared theta instead. And I said, if you can just remember the first one, then obviously you can see you can get to the other two. Cos squared over sine squared. Well, cos squared over sine squared is cot squared. You can see it from that trig identity there. Cot squared theta plus sine squared over sine squared equals 1. And 1 over sine squared we know to be cosec squared cosec squared theta. And there we have our new 3 trig identities, all derived from the equation of a circle, which is that first one. And then obviously if you can remember that one, you can get the other two by dividing by all by cos and all by sine. Okay, so again, you need to remember these formulas, or not formulas, I guess these trig identities, because they're going to help you with questions where you are asked to simplify expressions down. Okay, so let's have a look at some. I guess we'll start with some easier questions first, and then we'll get to some more challenging ones. So the question will simply say simplify. Okay, so we're going to have the first one. We might do tan theta times cos theta. Now remember, we can write the times as a little decimal place as well. Okay, so in order to simplify these, we need to somehow, I guess, manipulate either tan theta into an expression or identity that contains cos theta, or manipulate cos theta into an expression that contains tan theta. But this one for me is going to be a little bit easier because I know that tan theta is the same as saying sine theta over cos theta. Now the reason I've chosen that one particularly is because it contains cos in that particular identity. It says times cos theta. If you want to put it over 1 just to help you, you can. And now what you can do, you can either rewrite it as sine theta cos theta all over cos theta, or you might recognize that when you have 1 on top and 1 on bottom, they're being multiplied together, they cross out, because cos theta divided by cos theta is 1. So we're simply left with sine theta over 1, or just sine theta. Okay, so you can see how we've used our trig identities in order to simplify that expression down more. So look at this, the next one, tan theta times cosec theta. Now it might be an opportunity for you to pause this, have a go at this yourself, and then see if you're right. Okay, hopefully we've got tan theta. You said that tan theta is doing sine theta over cos theta. Now, one of the issues here, I can't change tan theta straight into cosec theta. So often what I do, if I'm not sure of how to do something, if I'm not sure where this is going, I just try changing the expression to something that I know. Just try and change it. You might find something that pops up. So sine theta over cos theta, I know that cosec theta is the inverse of sine theta, and look at that. We've got two common things. We've got sine theta on top and bottom. So now I can cancel because sine theta over sine theta cancels out, and I'm left now with 1 over cos theta. Now often if you left it like that, you know, it is simplified, I guess, but we can go in further because we know that 1 over cos theta is the same as having just sec theta. And so now I've got my answer there. Okay, I might circle my answers, make it look a bit easier. So I've changed it down to a nicer I guess expression. So let's have a look at the next one. We'll do sec theta times cot theta. Maybe pause it, have a crack at it, and then come back. Okay, so sec theta, well, we know that's 1 over cos theta. Cot theta is 1 over, now, if I change this to 1 over tan theta, because it is 1 over tan theta, okay, remember that other identity where we said that tan theta is sine theta over cos theta, which we already have done up here, but cot theta is a reciprocal of tan theta. So if this is my tan theta, the reciprocal of that would be cos theta over sine theta. Now you can do as much working out as you want. You know, you can even have 1 over tan theta in this part here, or do your working off somewhere close by. That's up to you and how much working out you do. So I've got my cos and cos, and that's the reason why I went into those two different formulas, because I need them to have something common in both sides. I'm now left with 1 over sine theta as my answer. But you might say, hey, hold on. I know that 1 over sine theta is the same as having cosec theta, and of course that's the preferable amount because it's much more simplified. Alrighty, we're doing pretty well so far. So let's up the ante just a little bit. Let's do 1 minus sine squared theta. Now I know my trig identity. I know that, I might do this in a different color, sine squared theta plus cos squared theta equals 1. So if I subtract what sine squared theta there, look, that's the same as there. So therefore, it equals simply cos squared theta. And that's my answer. Okay, so there's some of the basic styles of questions. What we want to do now is we're definitely going to up the ante to something a little bit more difficult. Okay? So harder questions. So again, actually I might say prove. Okay, prove. So let's say we've got cos squared theta minus 1 equals minus sine squared x. Okay, these are definitely the more challenging questions, but these ones I really I tend to enjoy, and I hope you do as well, because it's a bit of a challenge. You've been told that cos squared theta minus 1 is going to be equal to sine squared x. So you've been told what the answer is, but you need to figure out how to get there. So often what we start with, I start with left-hand side. Okay, this is a sort of guide. There's always different ways of doing things, but I like starting with the left-hand side. Okay, and as if that was my question, and saying, okay, well, if cos squared theta equals minus 1, let's simplify it. So I need to somehow figure out what we're doing here. So I know that cos squared theta plus sine squared theta equals 1. Okay, we know that. I also know that if I then subtract my sine squared theta, put it over this side, that was quite similar to the last question, then I've got cos squared theta equals 1 minus sine squared theta. So that's one thing I do know. Now, so I've got a cos squared theta there, and I've got a cos squared theta there. So let's substitute this into my cos squared theta. So I'm going to put there 1 minus sine squared theta, and I've got minus 1 there. Okay, 1 minus 1 is 0, so I'm left with minus sine squared theta, which is equal to my right hand side there. Okay, there is lots of different ways to do these questions. I'm just showing you one particular way. So again, I started with my left hand side and I tried to work it out until I had the same thing on my right hand side. Sometimes what you can do, instead of doing it that way, you can find an expression for the left hand side. Okay, find an expression for the right hand side and say therefore left hand side will be equal to right hand side. So that's another popular way to do things. Some people just like to have a crack at it and see what sort of comes out. Okay, so let's have a look at the next one. Remember this, we are, for these questions, we are proving. Okay, we're proving. So let's choose, let's do a little bit more interesting one. Let's do cot theta, this will be fairly tough, plus 2 sine theta, actually, so 2 sec theta, my bad, 2 sec theta equals 1 minus sine squared theta plus 2 sine theta all over sine theta cos theta. Now I know, look, that's a lot there, right? It is a lot there. So there's a big question. So I'm going to start by putting left hand side equals my cot theta plus 2 sec theta. That looks more manageable. So I'm going to try to rearrange this left hand side and see if I can somehow come out with what's on the right hand side. Okay, so I've got a few things. I've got cot there. Now, cot could possibly be a few different things. We know that cot is the inverse of sine. Sine is of inverse of tan. Tan can also be called sine theta over cos theta. So hopefully we're starting to recognize that cot theta is simply cos theta over sine theta. Okay, you'll start recognizing that hopefully. We've got 2 times sec theta. Now sec theta is 1 over cos theta. So I can rewrite it that way. All of a sudden you can start seeing some similarities. We've changed these two things here so far into sines and coses. Okay, so that probably tells me I'm on the right track. Now you can recognize, hopefully, that the answer here is all over one denominator. So let's try to do that here. We're going to try to put it over the same denominator. So I'm going to times the left hand by cos theta. What we do to the bottom must do to the top. And times the right one by sine theta. What do we do to the bottom must do to the top. So we've got cos theta times cos theta. Well, that's cos squared theta plus 2 sine theta. And it's going to be all over my sine theta cos theta. Okay. So let's have a quick look and see, are we getting close to things? Are we getting close to things? I'm getting pretty close, but my issue is this. I've got cos squared theta. Now, you might recognize that cos squared theta from one of the previous questions is equal to that. Okay? That's from saying that cos squared theta plus sine squared theta equals 1. So if I subtract that just to give my cos squared theta, that's what I'm left with. So I can actually now rewrite equals 1 minus sine squared theta plus 2 sine theta all over sine theta cos theta, which equals the right hand side. Now I know what you're saying. How on earth do I have to remember always to change everything? The good part about this is that I know what I'm working towards. I'm working towards that. I'm being shown what I'm working towards. So basically what I'm trying to recognize is what I've got. Like, for example, I realized I had the 2 sine theta correct. So, okay, that was sweet. But I recognized that, I had this, but I wanted that. So then I'm trying to figure out, well, how can I relate those two things together? How can I manipulate cos squared theta into changing it to do something 1 minus sine squared theta? And that's where I recognize, hold on, it might bring in that trig identity. It might mean to use that. Okay. Again, guys, this is difficult. It's going to be one of your most challenging aspects, I guess, of the trigonometry in this particular course. But it's fun. It's fun because you're trying to work towards something that's going to be quite difficult. Now, I'm going to give you the last question that's in exercise 6.11 of the textbook. This is, I think, 2J. So you can actually have a crack at this question and see if you can get it out. And then maybe pause it, and then see if you can see if you get it right or where you went wrong. Now you'll notice that in the book, often they don't always use theta. Okay, they might use beta, alpha. They might just say cos x, tan x. Remember, it just means an angle. For our purposes, I'm going to use theta. Just make sure that whatever the question gives you, you make sure you write the answer in. Okay, so tan theta plus cot theta. Alright, bit of a mouthful this one. So 1 plus cot theta over cosec theta minus cos theta is equal to sec theta over tan theta plus cot theta. Alright, so as always, I'm going to write LHS, so left hand side is equal to 1 plus cot theta all over cosec theta minus cos theta. So I look at my answer, I'm going to be needing to use tans at some stage, and sec, which is going to be 1 over cos. Ooh, that says something there. So I know I have to change a few things. So let's just see what we can change, or we can sort of manipulate, I guess. Okay, so if I look at this and say, okay, I've got 1 plus cot theta. I know there's no rule trig identities that has 1 plus cot theta. Alright, so what I'm going to do, I'm going to separate. And often separating your fractions is not a bad way to go. So I'm going to separate this, cosec theta, because what you might recognize when I'm separating this, that is a trig identity on its own. Okay, so cosec theta minus, and I'm going to put this as 1 over sec theta at the moment. Okay, you don't have to do that straight away. I've done that just because I've recognized that at some stage I'm going to need to change things. Okay, you're going to find that often you need to do a little working out here. I know that cot theta is cos over sine theta. So I'm going to need to have that there. I know that 1 over cosec theta, or cosec theta, sorry, is equal to 1 on sine theta. So if I'm doing cot theta, which is this, cos theta over sine theta, divided by, well, I don't like dividing, so I'm going to do times it by the reciprocal of this. They cancel out, so I've actually got cos theta there. So we've got 1 over cosec theta plus, I've changed this into simply just cos theta. Now, I changed this into 1 over sec theta, but I realised that actually it's going to be better to hold it in that respect. Equals now 1 over cosec theta is sine theta. Cos theta minus cos theta is 0. Well, not 0, or 0, it cancels each other out. So I've got left hand side equals sine theta. Okay, I'm going to need some more room here. I apologise for this. Now, I said to you sometimes I want to see if I can manipulate the left-hand side to be the same as the right-hand side. If that doesn't work, for example, I've got the sine theta left by itself. I'm going, okay, I can't really at the moment turn sine theta into this thing. So let's see if I could turn the right-hand side into sine theta as well. Because then, obviously, if they're the same, they're equal. So we've got sec theta over tan theta plus cot theta. Likewise, I'm going to separate this as a fraction. Actually, no, I'm not. Because if I separate it, I can't really separate, can I? So my apologies. I'm going to find what sec theta is. Sec theta, just so do my little working out. We know that sec theta equals 1 over cos theta. I know that. Let's simplify the tan theta plus cot theta. Well, tan theta is sine theta over cos theta plus cot theta. Well, that's the inverse of that. So it's cos theta over tan theta. Oops, sorry, sine theta. So which is equal to, multiply this by sine and this by cos. So sine squared theta plus cos squared theta all over sine theta cos theta. All I've done there is I've just multiplied the top and bottom of this side by sine, so then the denominators are the same. This top and bottom side by cos, so the denominators are the same, and added them. So now what I've got is this: 1 over cos theta divided by, now I don't want divide, so I'm going to turn it to a times. I'm going to flip these, sine theta cos theta all over sine squared theta plus cos squared theta. This is very complicated. I can see here that this sine squared cos theta, that equals actually 1, doesn't it? Because sine squared theta plus cos squared theta equals 1. I've got cos on the bottom, cos on top. So I'm actually left with 1 times sine theta is simply sine theta. 1 times 1 is 1, which equals the left-hand side. Guess what? They're equal. That is a really tough question, and I know it was probably a little bit confusing to follow me. As you can see, I did that from scratch, and so I had to make a couple of changes as I went, and realised that if I did change something, I may not need to have changed it. Look, questions aren't going to get much more challenging than that. If you got the right answer there, then you've done really, really well. As I said, start with the left-hand side, see if you can manipulate it to make it the right-hand side. If you can't, then see once you've got what left-hand side is equal to, because sometimes it might just equal 1, then let's see if you can manipulate the right hand side to get that same value. Okay, have a crack, guys. This is a really tough part of it, but this is the hardest bit in my view. Okay, hope this made some sort of sense. Hope you found it useful. If you didn't, if you thought it was God's will, let me know and I'll try to make an easy version. Enjoy.